Hi there. This video is on geometric proofs. So this first question asks us to prove that angle ABC is equal to angle CDE. So you could pause the video and have a go at it, and then I'll go over it. So when we're doing proofs, we need to look at the diagram and see what rules we can use. So we've got two pairs of parallel lines here, so we can use our angle rules on parallel lines. So this is angle ABC. So somehow we want to see whether that angle is equal to this one here. If we look at these two parallel lines, we can see that we have a pair of alternate angles. So that angle and that angle there are equal. So we start our proof off like this. Angle ABC is equal to angle BCD. And the reason for that is alternate angles on parallel lines are equal. Okay, so we want to include the reason so that if we're asked to prove something in an assessment, the reasons get us into that merit level. Okay, then we're looking at these sets of parallel lines here. Okay, so BC is parallel to DE. And you can see that we've got another pair of alternate angles. So this angle and this angle here. So angle BCD is equal to angle CDE. And that's for the same reason. Alternate angles on parallel lines are equal. So what we see here is that BCD is equal to angle CDE and angle ABC. Therefore, angle ABC is equal to angle CDE. So with geometric proofs, you need to come up with a few angles that lead you to the actual proof and also include your reasons. Moving on. So this next proof is for one of the basic triangle rules. The proof is showing that x plus y, that is this angle plus this angle, is equal to this angle here. We know that angles in a triangle add to 180, and then we also know that angles on a straight line, so those two angles there, also add to 180. Because those two expressions add to 180, we can make them equivalent to each other. So x plus y plus z is equal to z plus w. A little bit of algebra now. If I subtract z from both sides, so I'm not changing anything here, I'm doing the same thing to both sides of the equal sign, so I'm not actually changing the equation. I end up with just x plus y is equal to w. So if we have a look at an actual example, so I've got another triangle here. This is 30, that's 35, therefore this must be 115. So what is x? Well, we've got a straight line here. Angles on a straight line add to 180. So x plus 35 is equal to 180. So x must be 145 degrees. And that's due to angles on straight line add to 180. And let's just check that 145 is indeed that angle plus that angle, which is what this rule is saying here. Okay, that rule is saying that the two opposite interior angles added together will give you that exterior angle there. So 30 plus 115 does in fact equal 145. So this is another angle rule, and the way we word it is exterior angle of a triangle is equal to the sum of the opposite interior angles. So if you've got a triangle, you extend out one of the sides, then you obtain an exterior angle, and that angle is actually equal to the two opposite interior angles added together. So in this next proof, we're going to use that rule. So this example here, we're looking at proving that this angle, x, plus that angle there, plus z, will give us y. So we're going to prove this. When you've got a diagram, you can actually extend lines. So you've got this kind of funny angle here, but we can actually extend lines so that they cross right through both parallel lines. So we could extend that line out there if we wanted to. Okay, we're going to use this by doing some color coding here. So if I'm looking at x, that angle there, x, and that is vertically opposite with that angle there. So if I just put a brown dot there, those two angles are equal. And then the other thing I notice here is that AC is parallel to DF. So we've got some parallel lines, and we can use angles on parallel line rules. So if we look at this angle here, angle ABD, that angle is alternate with this angle. And we know that alternate angles are equal. Just grab another colour. And let's see if we can find some other angles that are the same. We've got another transversal going through here, so that transversal there, GI. So what I can say is that this angle, okay, that green dot there, is alternate with that angle there. So those two angles are also equal. They are alternate angles. So we actually have two triangles, this one here. So triangle BG, and I should actually name that point there, but this triangle here and triangle DGE, they are actually similar triangles in that they have exactly the same angles. If you look at this point G, these two angles, okay, so those angles in pink, they are vertically opposite, and vertically opposite angles are equal. If we look at this angle right here, so that angle there, that is vertically opposite with this angle. So vertically opposite angles are equal. So now we can employ the rule opposite interior angles are equal to the exterior angle of a triangle. So if you look at Y, okay, so this angle here, you can imagine that this triangle has a side that is extended out this way. So this would be the exterior angle. So that angle there, Y, is equal to this one, so that green dot plus that brown dot there. Okay, so in fact, if we look back at X and Z, that's a brown dot plus a green dot. So let's go ahead and actually form this proof. So the first thing we worked out was angle ABG is equal to x, and that's because of vertically opposite angles. Equal. And then we also worked out that that angle there, so ABG, is equal to GDE because they're alternate. So angle ABG is equal to angle, so that angle there would be EDG, and that's due to alternate angles on parallel lines. Then the next thing we worked out was these two green ones here. So those two angles are also alternate. So if we call those two angles, I will need to name this point here. So let's call that point K. Oops, so that point there is point K. So angle BKG is equal to angle GED, and that's also due to alternate angles. And then the two pink angles there, they are vertically opposite angles. So those two angles are labelled KGB or BGK. So angle BGK is equal to angle DGE, and that's because of vertically opposite angles are equal. So then we have that final rule that angle BKG, so this one here, BKG plus angle KBG, which is this angle here, are equal to, or is equal to y, and that's due to exterior angle is equal to sum of the opposite interior angles of a triangle. What we've also worked out is that angle KBG is equal to x, so KBG is equal to x due to vertically opposite angles, and then we also need to state that this green dot here, so angle BKG, is equal to FEI due to corresponding angles. So we need to write that here. I'll just write it underneath here. So just continuing my proof from here over to here. So angle BKG, sorry, I forgot the B. So BKG is equal to x, so we've already ascertained that here. And then angle BKG, so the same angle, is equal to angle FEI, and that's due to corresponding angles on parallel lines. Equal, and angle FEI is actually angle Z. So we're trying to prove that x plus z equals y. So we've actually come to the end of our proof, okay, because we know that this angle here is x, and BKG, which is equal to FEI, which is actually z, so that angle there is z. Therefore our last statement would be, therefore z plus x does in fact equal y. There's no one way to carry out these angle proofs. There are actually different ways because you can identify different angle rules, but the main thing is that you set out your work clearly and logically, labeling all your angles and giving reasons as you go. At the end of your proof, you want to make a final statement which proves the original question. So original question is asking you to prove this, so that's what we're trying to do, and then your final statement would be at the end, therefore z plus x equals y.